Hello everyone, this is Vijay Venkat. Uh, I'm from RMD Engineering College and I'm from Department of Science and Humanities. Let me introduce myself. My name is Kolatu Vijay Venkat, and I belongs to CSC, and I am going to showcase my first mini project of Engineering Mathematics 1, and my subject code is 21 MA 101, and I'm going to take Unit 1 matrices, and the mini project topic is matrix operations using MATLAB, and my faculty name is Mr. Satish Kumar sir, and I'm going to use the MATLAB to show the matrix operations, and let me introduce the topic matrices. A matrix refers to an ordered rectangular arrangement of numbers which are either real or complex or functions. We will enclose the matrix by square brackets or a parenthesis or pipelines. And if there are m rows and n columns, the matrix is said to be a m by n matrix, and we written as m cross n, and it is represented as follows. Mm, mm. And represented as follows. This is the m by n matrix. It is having this is a first row, and this is a second row, and this is a third row, and it is an mth row, and it is an first column, second column, and so on. It is an nth column. So this is called m by n a matrix. And for example, a matrix A of order 2 by 3. That is here there is having two rows and three columns. So it is a matrix of order 2 by 3. And let me introduce a topic called eigenvalues. The eigenvalues are nothing but the values of the roots of a characteristic equation. The mean is a determinant of a minus lambda I is equal to 0. If we take the roots of this equation, we will get roots as a characteristic roots. That is nothing but eigenvalues. Here we see the eigenvalues are the special set of scalars associated with a system of a linear equation. That is, if we if we reduce that determinant of ms lambda I, we will get an equation. If we solve that, we will get an able to eigenvalues, and it is mostly used in matrix equations. Eigen is a German word that means a proper or characteristic. It means it will be a proper value. Therefore, the term eigenvalue can be termed as the characteristic value. As before I said, the roots of characteristic equation is called a characteristic value or the eigenvalue. So the characteristic root or proper values are the latent roots as well. In simple words, the eigenvalue is a scalar that is used to transform the eigenvector. The basic equation is ax equal to lambda x. That means here this equation represents that this lambda is the eigenvalue of a matrix A. This is a specification of that equation, and the number or a scalar lambda is an eigenvalue of A. That means I told before. That's it. That means the lambda is an eigenvalue of the matrix A. Going to next, I am going to introduce the eigenvectors. That means the eigenvectors is nothing but the determinant of a minus lambda I into x equal to 0. Here the x is called the eigenvector. It means the column vector. Here the eigenvectors are vectors non-zero that do not change the direction when any linear transformation is applied. It changes by only a scalar factor. In brief, we can see if A is a linear transformation from a vector space V, the x is a vector in V which is not a zero vector, then V is an eigenvector of A if A of x is a scalar uh, multiple of x. That is, uh, let's say A is an 2 n by n matrix and a lambda is an eigenvalue of A, then x is a non-zero vector is called the eigenvector, if it satisfies the below expression, that is, I told before that Ax equal to lambda x, this is called an eigen vector expression. That is, the lambda is an eigenvalue of the matrix A. So if we take send this lambda x to the RHS, I mean, okay, then we will take the x's common and A minus lambda I. This I is called an identity matrix. We are taking the x's are common. Then if we multiply the lambda into I, we will get this lambda. So we will take like that. So a minus lambda I into x is equal to 0. Then x is called an eigenvector of A corresponding to the eigenvalue lambda. So now we are going to see the operations of the matrix using MATLAB. So MATLAB is a software which where we can do the all the matrix operations like addition, subtraction, multiplication, and inverse, transpose, and eigenvalue, determinant, and so on. So using this, I am going to show some operations of matrices. Now, I'm going to show that the matrix addition. This is the window of the MATLAB. So here I am assigning the A. So in this way, we need to assign a matrix that A is equal to, I have taken a square bracket and numbers, that is 1 comma 5 comma 9, and we need to keep a semicolon, which means it is going to be divided to the next row, and the 7 1 6, and with semicolon it will be next row, and 1 3 5. So these are a matrix of 3 by 3 order. That means if we press enter, we will be able to show that a matrix. That means 159 as a row 1, and 716 as a row 2, and 135 as a row 3. Similarly, I'm going to take another matrix B inside a square brackets, that is 8 4 0 in the row 1, and minus 8 3 minus 7 as a row 2, and 5 minus 1 4 as a row 3. If I press enter, I'm able to see the matrix B of 3 by 3 order. And then next line, if I press A plus B and press enter, I am going to just get the answer, that is 999 minus 1, 4 minus 1, and 629 as a third row. That is, now see, we will able to see this adding one means addition of two matrices means we are going to add the corresponding elements, that is a11 with of a2, a11 of b. That is, here 1 plus 8 gives 9, 5 plus 4 gives 9, and 9 plus 0 gives 9. Similarly, if we add all the corresponding elements of the two matrices, we will be able to get a plus b. And next, I'm going to show matrix subtraction. Similarly, I'm going to take another matrix of M, that is 1 minus 3 4 as a row 1, and dividing by semicolon, and 4 7 2 as a row 2, and divided by semicolon, and 5 2 6 as a row 3. And I'm going to take n, and in between the square brackets 5 6, minus 5 6 minus 2 as a row 1, 8 8 1 as a row 2, and minus 7 4 0 as a row 3. And when we press enter, we will able to see the matrix n. Now in the next line, if I type that is m minus n and the press enter, I am able to get the matrix subtraction. That means subtracting the corresponding elements, that is 1 minus of minus 5 gives 1 plus 5, that is a 6, and minus 3 minus 6 we will be able to get minus 9. Similarly, if you are going to subtract each and every corresponding elements, we will going to get this matrix. So next, I am going to show you a matrix multiplication. I am taking here a 2 by 2 matrix P, 1 3 as a row 1, and divided by semicolon, and minus 5 2 as a row 2. When I press enter, I am able to see P matrix 2 by 2 order, 1 3 as row 1, and minus 5 2 as a row 2. And again, I am going to take as a Q a second matrix of 2 by 2, 3 9, and minus 2 6. And the next line, if I am going to type that is a P into Q, I am going to get the answer as minus 327 minus 19 minus 33. If you will multiply P and Q separately, you will be able to see this answer. In this way, I have shown till now addition, subtraction, and multiplication. Now, I am going to show you how we need to find an eigen value of an matrix. Now, eigenvalue of a matrix. I have taken a 3 by 3 matrix of 0, 5, minus 10 as a row 1 and 0, 22, 16 as a row 2, 0, minus 10, minus 2 as a row 3. And when I press enter, I am able to see A of 3 by 3 ordered matrix. And I have taken B uh, of my order 2 by 2, 3 minus 1 as a row 1 and minus 1, 5 as a row 2. And here to find the eigenvalue of a vector, we need to use a function called EIG parenthesis. Inside the parenthesis, we need to write the matrix name, that is A or a B. I have going to find the eigenvalue of A. So EIG of A gives me the answer 0, 10, 10. If you are going to do by a paper and pen, you will be able to get the same answer as we get in the MATLAB. So again, I'm going to take eigenvalue of B. I'm going to get eigenvalue as a 2.588, 558 and 5.4142. Similarly, we can find eigenvalue of any uh, matrix. So now I'm going to check whether my eigenvalue of the matrix is correct or not. If we see the property of an eigenvalues, the first property is the sum of the eigenvalues is equal to the sum of the main diagonal elements, which is equal to the trace of the matrix. So similarly, if I check here, I got the eigenvalues of A matrix A as 0, 10, and 10. Now here same. I'm going to check the sum of the eigenvalues of A. Now here we get 0 plus 10 plus 10, we will be able to get us 20. Now here the function is sum of we need to keep a parenthesis, and in between the parenthesis we need to write the function as, that is eig of A. Then if you press enter, you will be able to see as 20, that is 0 plus 10 plus 10, you will get the answer as 20. And the trace of the matrix A is nothing but the sum of the main diagonal elements of the matrix, that is function trace of A gives the answer is 20. Then now we will be able to see that the eigenvalues of the given matrix is correct. That similarly, I am going to check out that property number 2. That is, the product of the eigenvalues is equal to the determinant of the matrix. So if we check the eigenvalues of a matrix is 0, 10, and 10. If you are going to multiply these values, you will be able to get 0. That is 0 into anything you will get as 0. So the product of the eigenvalue is 0. That is here as the sum we will have the other function of the product as prod P or OD, and then the parenthesis we need to give the function that is EIG of A. And when we press enter, we will be able to get as the 0 as the output. And similarly, as we find trace, we will having for determinant det of A. If we type det of A, we will be able to get 0, since we can verify that we are verified that the given eigenvalue of A is the matrix A is correct. So by the properties of the eigenvalues, we can able to check out our whether that our output of the eigenvalue is correct or not. Next, at last, I'm going to tell about some real world applications of the matrices. That is, first one is encryption. The one of the most common use of matrix in daily life is encryption. We use it to scramble data for security purposes. To encode and to decode this data, we need matrices. There is a key that helps that encode and decode the data which is generally generated by the matrices. That means in our day-to-day life we use the matrices for security purposes, and to encode and decode we use matrices. So in this way we are first application is using the matrices. And in construction purposes, one of the most common applications of matrices in real life is the construction sector. If we are going to construct, we need to take a plan, and how many floors we need to take, and where we need to place the bedroom, uh, and so on. And like this way, Have you seen some buildings that are straight, but sometimes architects try to change the outer structure of the buildings, like the famous Burj Khalifa, etc. This can be done using with matrices. That means uh, some architects will change the outer structure of the building. Um, it will be possible by using the matrix. So a matrix is made of a row and column that you can change the number of rows and columns within the matrix. So matrix can help support various historical structures. So like this, the second application of the matrices is using construction. And if you go and so on, matrices have many other applications in diverse fields of science, commerce, and social science. Some of them are computer graphics, optics, cryptography, economics, chemistry, geology, robotics and animation, wireless communication, and signal processing, finance. Like this, not only this, there are many real-world applications of the matrices. These are all the some of the real-world applications we will be able to see many where everywhere we are using the matrices. So, uh, let me conclude my session. Thanks for everyone.